So, like, the first way to factor, the first thing we always look for is we always look for GCF. And then we look for, like, difference of perfect squares or sum or difference of cubes. And then we have the AC method. We can complete the square if we need to, which we won't ever do that. We can do grouping. When do we do grouping? When we have how many terms? 4. Okay. And then if we can't do grouping, then we can go with our possible zeros, which then, if we do our possible zeros, we also have to do synthetic division or long division, one of the two. Typically, I think we prefer synthetic. It seems like way less work. We had started this problem. We had decided we couldn't group this problem because there was 5 terms, so we can't group with 5 terms. We had... All right, so we decided we couldn't group this, so then our next option, we can't do any other factoring method, so then we have to do our possible roots. So possible roots, we got to find our factors of 8 and our factors of 1. Our factors of 8 are 1, 2, 4, and 8. Our factors of 1 are just 1, and then we divided those, and we got positive, negative 1, positive and negative 2, positive and negative 4, positive and negative 8, and we plugged them in, and we got 2 zeros based on this information. So what 2 zeros do we currently have? 1 and negative 2. So we know that 1 is a 0, and negative 2 is a 0, which means that we could also produce factors from those. We currently know 2 factors. Then what's one of our factors at this point? Okay, so those are our 2 factors that we know, not necessarily the only 2 factors that exist. And that's what we have to figure out now by doing synthetic division. That's where we left off yesterday, was we hadn't gotten to that part. So we have to synthetically divide. So I'm going to put which 0, and it does not matter the answer to this question. It's up to you guys. Which 0 do you guys want to do first? Do y'all want to do 1 or do you want to do negative 2? Okay, I heard negative 2 the loudest, so I'm going to go with that one. Okay, so I'm going to put negative 2 out here. And then what goes on the inside of my synthetic division box? 1, 5, 6, negative 4, and negative 8. All my coefficients. Okay, so when I do synthetic division, the first thing I always do is I bring down the 1. Then what do? Multiply it by negative 2. So 1 times negative 2, which is... negative 2. And then 5 minus 2 is 3. You were just a step ahead. We're good. Okay, and then 3 times negative 2. Negative 6. And 6 minus 6 is 0. And then 0 times negative 2. 0. And negative 4 plus 0 is 4. And then negative 4 times negative 2 is, and 8 minus 8 is 0. And we should have gotten 0 there. How do we know we should have gotten 0 there? Because negative 2 is a factor. We already figured that out, that when we plugged in negative 2, we got 0, which means our remainder is 0. That's the remainder theorem. So if you plug something in, then what you get is equal, what you get that equal to is your remainder. So don't write what I'm about to write. Okay, don't write this. So what we know now, starting from the end, this is my remainder. This negative 4 is my constant, and then 0 is, and then. So if I wrote that out, don't write this. This would be x cubed plus 3x squared plus 0x, I'm not going to write that, minus 4. And if I multiplied that by x plus 2, again, don't write this. What would happen? First of all, where did I get this x plus 2 from? Okay, it's your factor because our 0 was negative 2, so my factor is x plus 2. What would happen if I were to multiply these two back out? Yeah, I would get this original problem, x to the 4th, blah, 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 minus 8. Okay, that's what I would come up with. But we're not done, and why aren't we done with this problem? We have another 0. So I have to do synthetic division again. So here's my question. Do I do synthetic division with my original polynomial or with my new polynomial x to the 3rd plus 3x squared minus 4? I do it with the new one. Because if I do it with the new one, then that's going to take that to something even smaller and something we're going to be able to work with. So I already have my coefficients. So I'm just going to draw another box, and I'm going to put negative 2, or sorry, not negative 2, positive 1, because that is my 0, and I'm going to do synthetic division here. So I don't want you to write that, because then we're just going to rewrite something again that we already have written, and why do that? So now I get to do synthetic division a second time, so I'm going to bring down my 1. Helps if I use my pen, not my highlighter. Bring down 1, and then what do? Multiply it by 1. So 1 times 1 is 1. And 3 plus 1 is 4. And then I multiply 4 times 1, which is 4. 0 plus 4 is 4. And then I do 4 times 1, which is 4. And 4 minus 4 is 0. Okay. Do I keep going? I know the next one's going to be 0, and think about it. What was this 0 right here? The remainder. This was our remainder, so it's technically not even there. So now this is my remainder, which it should be my remainder, because I should have gotten a remainder of 0, because when we plugged it in, it gave us 0. So talk to me about this right here, these coefficients. What would this, what's written in green here, be expressed as if I were to write it as a polynomial? X squared plus 4x plus 4. It's okay. It'd be x squared plus 4x plus 4. And then what were my two factors that we already have established?
X minus 1 and x plus 2.
Okay. So this is my factorization at this point. Can I factor it again? I could do quadratic formula or AC method. This one factors. X squared plus 4x plus 4, that factors. Tell me what two numbers multiply to give you 4 and also add to give you 4. 2 and 2. So x squared plus 4x plus 4 is really x plus 2 times x plus 2. And then I still have an x minus 1. And I have another x plus 2. Yes, I could rewrite it and just literally make it look better and write it as x plus 2 to the third. And the reason I can do that is because there's 3 of them. So because I had 3 x plus 2's, so I can write this as x plus 2 to the third power. And then I still have my x minus 1. So if this is my complete factorization, then what are my actual zeros? What are my solutions? Negative 2 and positive 1. What can you tell me about the one with a negative 2? So that means it has a multiplicity of 3. So negative 2 has a multiplicity of 3. So problem 5, we're looking at that one. What kind of problem is this? It's a difference of cubes. So that one is going to factor well because it's a difference of cubes. Do y'all have the difference of cubes formula written anywhere?
No.
Okay. So let me write them up here for you. So sum of cubes a cubed plus b cubed is a plus b times a. I'm giving you both of them. Minus ab times
We don't even know.
Okay, and then this difference of cubes.
A minus a cubed minus b cubed. A minus. Okay, so whenever you factor that x squared plus 4, that's not there. Oh god.
So these are your sum and difference of cubes. I would either write them down and take a picture of them just so you have them handy. But those are the two formulas for those. I always told you never have to memorize them. I'll always give them to you. So they will be given to you on your test as well. Okay? So those are the two formulas. So this problem is a difference of cubes. Just for the sake of just identifying stuff, what is A in this problem? No.
Oh, I mean,
2. It is 2x because A is whatever is cubed to give you 8x cubed. So that means what can you multiply by itself 3 times to give you 8x cubed? And that'd be 2x, 2x, and 2x. So then B would be 3 in this problem. Okay? Again, I'm not going to make you do that because I think that sum and difference of cubes is one of the easier ones. It's just 3. The signs are taken care of by the signs in the formula. So you just worry about the number itself. So in these parentheses, what can you tell me about this one? Is there something specific I told you about this last parentheses here? It can or it can't? It can never be factored. So in order to solve this parentheses, what do you always have to use?
the quadratic formula.
Mm-hmm. Go. All right, so we have x to the 4th minus 13x cubed plus 55x squared minus 91x. Okay, thought is to group it.
We can take out an x. Yeah.
Let's take out the GCF first. So if I take out the x, then I'm left with x to the 3rd minus 13x squared plus 55x minus 91. And now it has 4 terms, so your default thought is grouping. Okay, so don't write this. If I were to group this, don't write this. If I were to group this, what do those first two have in common? And then I'm left with x minus 13. What about 55 and negative 91?
Wait, 13? No.
So, okay, 55 is divisible by 5 and 11, and 91 is divisible by 13 and 7.
So you have to.
That's it. Do they have anything in common?
No.
So you can't factor anything out of this. So you can't group this problem because it doesn't work out. That's why I told you not to write it. Because I didn't want you to waste your time writing something that I knew wasn't going to work out. Okay, so what can I do then if I can't use grouping? What can I do?
Could do 0.
You could find the rational zeros.
I can find the rational zeros. I can find my possible zeros. Okay, so to find my possible zeros, I need my factors of 91 divided by my factors of 1. Okay, what are my factors of 91? Do what? 91, obviously. And 1, and 13 and 7. There's no more. And the way you can tell there's no more is because think about 13 and 7. Can you factor 13 and 7 at all? Because they're both prime, so there's no other way to factor 91. What about 1? 1. Oh, sweet. That wasn't too bad, was it?
No.
Okay. So I'm going to make my little T-chart over here. And then here I'm going to put my divisions. So I have 91 divided by 1, which is 91. So we have negative 91 and positive 91. And then 1 divided by 1 is 1. So positive 1 and negative 1. What's my next set of numbers in here?
Negative 13.
And then negative 7 and 7. Okay. So what do we do with each of those numbers? Plug them in. So negative 91 was not 0. It was some really big number. What about positive 91? Not 0? Okay. What about 1? Negative 1? 98? Is that what you said?
Negative 1. Sorry, it's
110? 110? Okay. What about 13?
Negative 338.
Negative 13?
59,150.
Not 0. Negative 7?
Not 0.
What was positive 7? 0. One of them was 0. Was it positive 7 or negative 7? Positive 7. Okay, I was like, I knew one of them was. So positive 7 gave us a value of 0. So if we know positive 7 is a 0, then we know one factor is x minus 7. We've got that down. And what can we do to find the other factors? What do we do? Synthetic division. Yay! Yay! Okay, so what goes outside? Positive 7, sorry. You're right. My bad. Okay, and then inside, what are my coefficients? Ooh, wait, this brings up a good question. So when I do synthetic division, do I go back to my original problem, or do I use this problem that's in parentheses here? Okay, which of these two problems did we use to get our rational zeros?
The second.
The second one, we used the parentheses, didn't we? Could we have used the first one? No. Because what's in the first problem, the original problem, what's my constant? There isn't one, so that technically makes it a 0. So I can't use that one. I have to use x cubed minus 13x squared plus 55x minus 91. So 1, negative 13, 55, and negative 91. Okay, so what do?
Bring down the 1.
Bring down the 1, and then 1 times 7 is 7. And negative 13 and 7 is negative 6. And then negative 6 times 7 is negative 42. And 55 minus 42 is 13. And then 13 times 7, 91. And negative 91 and positive 91 is 0, which it should have given us 0. And that's a good indicator to know if you did it right or wrong, because if we didn't get 0, what does that tell us? Something's wrong. Whether we plugged it in wrong or we did our synthetic division wrong, because those two should always give us the same thing. So what is this new equation? Wait, do I do synthetic division again?
No.
Why not? I only had 1 0. So now I can just take this function that I've ended up with here. I think it's my dividend. Isn't that what's left over like after you divide? Sounds about right. I don't know either. Okay. Clearly that's a vocabulary word that's affected my life. All right. So starting from the end, 0 is my 13 is
Constant.
negative 6.
X.
And 1.
X squared.
So my function is x squared minus 6x plus 13. We can. What else have we already factored out of this?
An X.
An x and an x minus 7. We factored out all 3 of those. The x was our GCF, and by synthetically dividing by positive 7, that means I factored out an x minus 7.
It's just like taking different ways of factoring and just doing it, because you can't do it all one way.
Exactly. So we're just kind of putting all the ways we've learned together. I know, it's so fun. This is called finding solutions. It's like finding zeros or finding the solutions of polynomials. Or factoring polynomials completely. It kind of goes under a bunch of different things. Your book calls it finding complex solutions, because this is the first time we've really dealt with imaginary solutions in our polynomials. But it kind of all falls under the same like general category. So if I ask you then to find the zeros of this function, well, you can easily tell me 2. What's one of my zeros? 0. And then what's the other one we can easily identify? 7. And then how would I have to find, what would I have to do to find this one? Why can't you factor it?
Because 13 is a factor.
And there's no way to get 6 from the factors of 13. So this one doesn't factor. You would have to do quadratic formula. And that would give you how many total solutions?
2.
In total, though, all of them together. You'd end up with 4. And how many should we have had from the beginning? 4, because it was x to the 4th. I'm not going to make you do quadratic formula because I think that's something y'all are capable of doing. Okay?